Okay, welcome everyone to this lectures. Today we'd like to talk about three topics. First one will be talking about the classroom classifications, what we'll include for these lectures. Moving on to next. So first one we'll talk about what is a clean room classifications. As you can see that on the bottom tables, this is the ISO 14644 1-1 and this class 1 and ISOs. We'll talk about that in the next slide. And then number two, what is required for air change for each class? You may be wondering for this question. Number three, what is ISO class for different industries? What they are using? Okay, moving on to the next one. So a classroom class, a clean room class is determined by this concentration of the particles of various sizes ranges from 1 micron to zero point 0.5 microns, which is determined by this ISO standard 14644-1. And then one thing to point out is first of all, most of the contaminant came from human beings, and so those are pretty large particles, as you can see, if you can see from your naked eye. And as you can see this chart at the bottom, the size of the particle on this chart are indicated in micrometers, and however, nanometers, which is the size of the feature on the chips, are described in the nanometers. So which is one tenth, which is 1/10,000th of the micrometers. So you can get a sense of, how big a difference that there is. In another word, clean rooms are classified according to the cleanness level of the air inside a controlled environment. This is very well known. And the clean room class is the level of the cleanness the room comply with according to the quantity and size of the particles per cubic meter of the air. So the dirtiest we can see on the table is ISO 9, the cleanest is ISO 1, and ISO 9 is the lowest level of the clean room standard equates to the ambient air in a typical city environment. So this is kind of what we are talking about before the different levels of ISOs. Uh, so you can see these comparison tables. So in the past, many years ago, I used to hear about class 1, class 2, 10, class 100. The industry kind of changing a little bit more toward to the ISO on the left now. So for a lot of major semiconductor companies, ISO 3 normally is the baseline where we have seen a lot of design, a lot of our semiconductor fabs around nowadays. But this one chart requirement alone basically detects how we design the clean room. And it change everything from the amount of filter we have, for examples, and the type of filter we need to use. Those are different requirements for those. For examples, if you have a HEPA versus the old BOBAs, I'll get into those in a little bit more, but always change how we design the facility and what requirements goes into those. And also, for example, you would think about do you have a liner panel for those? So all those features, all those will add up and the cost then to the next levels, to the upper level, higher levels. And the clean room levels, so the higher the level the clean room is, the higher the cost there will be. So there's a lot of different requirements to support this system for sure. And the most interesting is that there's different ways you can save money by when you get to the higher level of the ISO for ISO 708. You can do a lot of the air inject that is pen in epoxy paint, and also sometimes there's some tips. For example, it doesn't actually have to be laminar floor, so you don't need to flow in one unit directions. Um, through the in these higher levels of the ISOs. You just need a lower return, so that save a big chunk of the money. And so there's a lot of variation you can play with when you're doing this clean room design, and to think about that. Um, okay, so long for this one. So moving on to next one. So number two, it's what is the required of the air change for each class. As you can see, depending on your levels of the clean room here, depending on the amount of air change, um, so ISO 2, you will need 80 to 100%. That's a very high level, as we can see. And ISO 3, also you need 5 to 750 air change per hour with a ceiling coverage of 60 to 100. So the more air change, you bring more clean air, so you can remove those particles out of there. And okay, so that's the next part is filters. So filter is referring to the ceiling coverage. So what it means by that is the amount of filter you have over a percentage areas. So when you get into the class one, when you get into the class which is the ISO 3, you will need to have the 100% filter coverage areas. And you know what that means? You don't have a space. You have to have a special ceiling system just so you could accommodate lightning to put on, and because you need this light integrate into the ceiling system, or you need to be suspended from the below. So those are things you need to think about for those. Also, these filters become extremely heavy. So when you sometimes have a well module ceilings, clean room ceilings, you sometimes you will need to have stick built ceiling systems. So it's interesting. There's a whole variety of different types of ceiling system when you design a clean room, and it's all dedicated a lot on the type of the percentage of filter coverage for the system to be used. So it is extremely important to specifying the right product, the right setting system for the right applications. So when you designing this clean room, okay, good. Moving on to next. So next one we talk about um, what is the ISO class for different industry. So this slide here is basically a summary to show is how there's a different types level of clean room, and this one shows class 5 for semiconductors. But you know, we normally in the industry semiconductor fabrication facility, they are designing ISO 4, sometimes ISO 3, based on industry use and what the their requirement are. uh, so they are obviously gonna want to figure out what the most cost-effective mechanical system is to reach the sort of thousands levels, thunderous levels on that requirement. So obviously not everything is required the highest level, which is the ISO one. So this is pretty much for this lecture. I hope you guys enjoy it. I'll see you in the next lecture. Thank you. Bye.